All right, we're looking at trig identities in this video. Now, a lot of these you can actually prove pretty quickly from the unit circle. So for example, this one here, if we look at an angle of theta there on our unit circle, use my drawing skills, and we had a look at the angle across from that, this angle is actually pi take theta, because it's the whole 180 degrees take away what this would be theta from the other side as well. And the point is, these have the same height. So in other words, they both have the same sine value. So in other words, the sine value of that first angle theta should be the same as sine of pi take theta, which is one of those identities. And you can essentially prove all 6 of these using similar methods. If you ever want to try these bottom 2, which I would recommend, you can actually use your SACE definition. I'd recommend trying that as an exercise. It's lots of fun. We've also got these. A lot of these you can prove using SACE or the unit circle as well. Now, we've got to simplify some expressions. So what we've got here is sine of minus theta. Now that was minus sine of theta. And 2 sine of theta. So that just becomes sine of theta. Okay, now, one method that you can use to double check these is I've actually graphed that first one, sine of minus theta and 2 sine of theta in the calculator. And then I'm going to look at what that looks like in a picture. I'm also going to graph what I thought the answer was, sine of x, sine of theta. And hopefully those graphs should overlap if we draw them. Yes and yes. So that's how you can check you got it right. Well, at least you're pretty sure you got it right if that's the case. Something like this, the top answer is sine of theta. And then the bottom answer, cos of pi take theta, that's going to be minus cos of theta. I sort of know these identities after too many years looking at them, but you will have to scroll up and double check. So I used, for example, that one there and that one there. Okay. This becomes minus sine theta over cos theta, which is tan theta. And that's another identity. There it is, tan theta. Okay. Something like this one. Generally, factorization is a good strategy here. So I'm going to go 2 lots of 1 take sine squared theta. Now, because I sort of know what I'm looking for here, whenever I see a sine squared, I'm really keen to use this identity here. Sine squared plus cos squared is 1. And in particular, if you rearrange that, sine squared is 1 take cos squared. Or cos squared is 1 take sine squared, which I think we have. So if you ever see 1 take sine squared, you can just replace that with cos squared. So that would become 2 cos squared theta, just like that. Yeah, if you're wondering what the cos squared means, that is 2 times the entire thing of cos of theta all squared. That's what that means. Okay, here I'm going to use the same method and try and pull out a common factor of sine theta. What I'm going to be left with is cos squared theta for the first term and sine squared theta for the second term. And what do you know? That thing is just 1. Trig identity, so this thing is sine of theta. Okay, cos squared take sine, cos take sine all squared. So what we need to do is use this identity. A take b squared is a squared take 2ab plus b squared. Or you could just write this as cos theta takes sine theta times itself if you forgot that identity or something. That would also work. But I'm going to do the first thing squared. So that is cos squared theta. 2 times the first thing times the second thing. And sine squared theta. So this becomes, well, we can group the cos squared and the plus sine squared into 1. That's how that works. And then we're just going to be taking 2 cos of theta, sine of theta. And usually if this was like a show that question, I'd be saying, at least saying something like trig identity. But if it was like a proof or a show that, I'd be saying sine squared theta plus cos squared theta equals 1 as like an explanation for that step. By the way, we will very soon learn another identity to simplify that one down. And this is by far not all the trig identities. If you do Year 12 Specialist Maths, which I highly recommend, this is the SACE formula sheet. And it's got heaps of trig identities on there. All those wonderful ones on the edge there. And even this list on the SACE formula sheet is not the full list of trig identities. And you might notice that some of the ones from this video are not on the SACE formula sheet. So these ones, I guess they sort of expect you to know by the time you get into year 12. And if you ever forget one of these trig identities and you're like, oh, dang, what did sine of minus theta equal again? You can literally just go like, okay, sine of minus 2 or something. And if I check it against sine of 2, I'm like, oh yeah, sine of minus 2 is just negative what sine of 2 is. And then that would give you back that identity, even if you didn't have it on a cheat sheet or something. But especially for year 11, please put these on a cheat sheet. They're very useful.